penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bervisi Guru AYU, mencapai misi yang satu, bervisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hi, Salam, Sejahtera, dan good afternoon everyone. Welcome to Pusat Tuisyen Akademi Youtuber with the joint venture of eDidik Malaysia and Guru Malaysia. Are you able to hear me? If let's say you cannot hear me, please respond to the chat room. So I am Mr.Peh. Currently I am teaching at College Tingkatan 6 Tun Fatimah Melaka, and I am the teacher on duty for this week. So in this afternoon, we broadcast live from my channel, Cikgu Peh channel. So for those who haven't subscribed my channel, please press the subscribe button to show your support to me. And for today's lesson, we are going to continue the subtopic of chapter 5. So that is the interference of the wave. And there are total about 5 learning standards you are going to learn today. So will be cover of the interference of the water, sound, and together with light. And then the last part, the learning standard 5 will be regarding the application of the interference of the wave. So on this week, we have 2 classes of physics. There is the first will be Form 4, like today, every Sunday, 3:30 p.m. And another class will be actually already conducted last Friday, presented by Cikgu Rina Rashid. And the Form 5 class is actually now already at the subtopic of Chapter 7.1. Theory quantum cahaya. Okay, let's say you miss the class, you may go to the channel Cikgu Rina Rashid for the class. Okay, so without further ado, let us start our class. Okay, so as per mentioned just now, today we are going to learn about 5 learning standards. So the first learning standard, you must able to explain the principle of superposition of the wave. Okay, so firstly, you need to know the definition of the interference of the wave. Okay, so you can just observe the first GIF will be this. Okay, so you can see the person using 2 ball vibrate. So because they want to create 2 circular wave here. Okay, and then you can see the interference effect is occur. Okay, just like the figure. Okay, and then the second GIF here, we're using the blank wave, and then pass through 2 gaps. And you can see the effects of the interference will be also appear. Okay. Okay, so the definition will be like this. So the effect of the superposition of 2 or more waves from the coherent source of the wave. So here the coherent source will be referring to the first GIF will be 2 yellow ball, okay, vibrate by the man. And then the second GIF here will be, you can see the blank wave pass through the 2 gates and form the interference effect from 2 coherent sources. Okay, so what is the means by the coherent sources here? Okay, so coherent sources are the 2 sources of the wave, which produce wave with the same frequency, same wavelength, and the phase difference is constant. Okay, so this is a 3 characteristic for the coherent sources. Same frequency, same wavelength. I think all of you must able to understand. Okay, so what means the meanings by the phase difference is constant? Okay, so here you can look at the figure, this figure, coherent source of the wave. So here we have the 2 waves here. So from the figure, you can see the wavelength from the start of the cycle and the next cycle. The wavelength is same as the bottom. Okay, and then secondly, okay, so you can see first, same wavelength for both 1 and 2 wave here. Okay, so for the wavelength same, the frequency will be also the same for the wave. Okay, then the second, here we want to discuss about the phase difference. Okay, so what is the phase difference? So look at this segment. So the phase difference between 2 waves is the same for all positions along the wave. These 2 waves have the constant phase difference between them. Okay, what means by this? Okay, so initially you can look at this first line. So the first wave is at the crest, and the second wave, the position is just after the crest. Okay, and then if I say the wave is moving with the same distance, okay, so firstly you see, okay, so I want to show you that the initial point, both the wave is actually have different phase. The first wave will be at the crest. Then the second wave here is actually just after the crest here. Okay, then the next distance with the same distance, you can see the first wavelength, the first position of the wave is still at the crest. Then the position of the second wave here, you can see, is also after the crest. So you can see the phase difference is actually same along the wave, right? So you can look at the third point. Okay, so here same position of different phase now. So at the third line here, you can see again, the first wave will be at the crest. Then the second wave is at the position after the crest. So the position of the different phase here is actually constant, where is showing that this is the coherent source of the wave. Okay, so for the 2 wave with same frequency and wavelength, they will be actually together come with the phase difference will be constant, where I show you now. So you can see the wave at the top is always at the crest, and then after the second wave will be after the crest. So this is mean by phase difference is constant. Okay, so now I want to show you the second non-coherent source of the wave. You can see these 2 waves, the wavelength is different. So the top one, the first wave is longer wavelength, and then for the second wave at the bottom, so the wavelength is actually shorter. So they will be considered not a coherent source already. Okay, firstly, wave not same, the frequency also not the same. Okay, then the next here will be the phase difference between 2 waves is the not same for all position along the wave. Okay, so again, the starting point from the bottom wave 2 is at the trough. Then for the top one is after the crest. Okay, so with the same distance, where will be another wavelength for the bottom wave, still at the crest, at the trough, but you can see the top face, the position is before the crest. So you can see, okay, so the different phase is not the same along the wave. Okay, so this is considered not a coherent sources. Okay, so to let the interference of wave occur, so the two or more wave here must be same frequency, same wavelength, and together with phase difference must be constant. Okay, so I hope that all of you can understand what is the meanings of the phase difference is constant here. Okay, then the second, you need to understand the principle of the superposition. Okay, so what is the principle of superposition here? Okay, so the statement will be like this. So when two waves overlap, the resultant amplitude is equal to the sum of the amplitude of the two individual waves here. Okay. So at the meeting point, so when both the wave overlapping each other, okay, so when they meet together, so the new amplitude or the resultant amplitude will be plus both of the amplitude. Okay, so at the meeting point, the two waves will be combined to give a resultant wave whose amplitude may be greater or less than the original two wave. Okay, so can be greater, amplitude can be less. Okay, so here is actually can be classified to two types of superposition. Okay, so the first type will be construction, superposition. Another type will be destruction of superposition. So construction, that means here the resultant wave will be have greater amplitude. Okay, so you can look at this figure. Okay, so the resultant amplitude increases when two waves meet. Okay, so you can see before that, both we have two coherent sources here are going to overlapping to each other. Okay, so the first here will be to the right, and then the second here go to the left. Okay, so that during the superposition, they will be overlapping each other. Okay, so the new amplitude will be positive. For the crest will be positive lah. So A plus A will be 2A. So you see the amplitude already double. So then after the superposition, respective crests will be moving in opposite direction. Okay. Okay, then for the destructive superposition, okay, so the resultant wave will be actually become zero or decrease here. Okay, so here on the box, red box here showing that this is the resultant of the overlapping for constructive superposition, which is double up here. Okay, then for the destructive superposition, okay, so the resultant amplitude decreases. Okay, when two waves meet. Okay, so here again, you can look at the figure, this figure before superposition. Okay, you can see this wave is at positive amplitude, which is crest. Okay, and then the second one here will be trough. Okay, will be have a negative amplitude. Okay, so both will be overlapping during the superposition. You can see positive A minus A. When we add together, becomes zero. So that means during the superposition, there will be no any wave will be formed. Okay, so after superposition, the both respective wave will be moving opposite to each other, and the amplitude will be same as the before superposition. Okay, so this is two types of superposition. Okay, so you can see here during superposition, so the wave will be zero lah. Okay, the resultant wave will be zero. Okay, then we go to the type of the interference. Okay, so just now I already introduced to you. So the principle of superposition will be form two different types of superposition, which is construction and destruction. So the construction will make the resultant wave have greater amplitude, while for the destruction, they will have 0 or less for the resultant wave. Okay, so that means here the type of the interference is also depends on the principle of superposition. Okay, so the first type will be known as constructive interference. So for sure that they will meet the constructive superposition where the resultant wave will be greater lah for the amplitude. Okay, another type will be the destructive interference. Okay, so for constructive interference, so the effect of superposition that means two waves will be overlapping each other. Okay, so two can become from the two wave which is crest will be at this case A now I put it as A, or two wave will be trough will be B. Oh, this is trough. Okay, so the effect will be generate maximum amplitude. Okay, so for the two wave of the crest overlapping each other, so will be given positive amplitude. Then for the two wave trough overlapping each other, so will be given maximum negative amplitude, just like the figure here. Okay, then the next here will be the destructive interference. Okay, so the effect of the definition will be the effect of the superposition of one wave crest and one wave trough from the coherent sources to produce 0 amplitude here. So you can see here, this is a crest, wave from the crest, and then here will be the wave from the trough. So will be form 0 amplitude lah. So they will be same for the bottom. Okay, so second terms you need to understand here will be the anti-knot. Okay, so what is the anti-knot? So the anti-knot is the point where the constructive interference occur. So you can see here, crest meets with another crest. So there will be constructive interference occur. Together we also the case for trough meet to another trough of the wave. So these 2 points we know as a anti-knot. Okay, so that means here the anti-knot will be occur for the point where the resultant wave come from the two crests overlapping each other or two trough of the wave overlapping each other. Okay, so then for the knot, so the knot here will be defined as where the point, the destruction interference occur. Okay, so here you can see from the case here, when crest of the wave meets to the trough of the wave, so will be 0 amplitude. Okay, so this is known as a point and known as the knot here. So that means here, two of these conditions will be knot. Okay, then the next, okay, so we have already finished the discussion regarding the learning standard 1. Okay, so now let us test whether you understand the learning standard 1 or not. Okay, so this is the objective question from the past year question of 2008. Okay, so diagram, okay, in which diagram will destructive occur when the wave meets? Okay, so here, just now we just learned, right? Okay, so the destructive interference will be occur when one wave crest and one wave trough from coherent sources overlapping to each other, right? So it'll be like these two cases, crest meet with trough or trough meet with the crest. Okay, so the answer will be clear, right? So this one will be crest, here will be trough. So this is actually the answer A lah, huh? Okay. Okay, so for B, there will be crest meet with crest. So this will be form constructive interference. Okay, then C is actually no any interference will be occur because both is zero amplitude. Okay, then case D will be two wave trough overlapping each other. So will be form constructive interference also. Okay, so answer ratio will be A. Okay, then the next here will be question number 2 from SPM 2009. Okay, so diagram 18 shows two coherent source, two coherent wave propagate towards each other. Okay, so here is the two wave mentioned by the question. Okay, so which diagram is correct when both wave meet? Okay, so here we need to apply the principle, superposition principle, right? Okay, so when two of the wave overlapping each other, so we need to sum of their amplitude. So for the first, there will be 1 cm minus, this one is trough, actually it's minus. Okay, it's minus 1 plus, this is a crest, so will be positive 1. So end out we get 0. So that means here will be 0 amplitude. Okay, so answer very clear. There will be C. Okay, then the next here, question number 3 is also the past year question. Okay, so from 2015. Okay, so diagram 24 shows two waves moving at the opposite direction. Okay, opposite direction. One, this one will be to right and this one will be to the left and meets at point out. Okay, so that means interference will be occur. Okay, so what is the resultant amplitude of the wave at the point out here? Okay, so they will be overlapping at the point out. Okay, so again, we're using the principle of superposition. Okay, so we need to sum of their amplitude. Okay, so for the first here will be x, positive x, because it's a crest. Then the second here will be positive 2x. So we add on, we get 3x. So answer will be D. Okay, then the next here. Okay, so I just saw the reply from the Cikgu Rashid. Cikgu Rina Rashid, okay, so thank you for joining my class. Okay, yeah, I call your name because you are the presenter for this week. Okay, so another one is all of you actually can get my worksheet, okay, for today's lesson through the link, okay, through this link, okay, so you may get the worksheet for today's lesson, okay. Please get through via MO email. Okay, so let us continue for next question. Okay, so question number 4 also regarding the question for learning standard 1. Okay, so here diagram 21 shows two wave pulses produced at P and Q. So here will be P and Q. Okay, so the P and Q are at the same distance from X. So that means they will be overlapping each other and the interference will be occur at X. Okay, so firstly, when both hands shaking up down, so the both wave will be moving at the opposite direction. So they will be meet at point X here. Okay, so the P will be at amplitude A. Q also the same. Both is a crest, so that means positive A together with positive A. So again, we're using the principle of superposition. Okay, so the constructive interference will be occur. Okay, where crest P and crest Q is meet together at X here. So answer very clear. There will be 2A at the crest. So answer will be A. Okay, then the next here will be, okay, so we are going to learn, okay, learning standard 2, learning standard 3 and 4 together. Okay, Okay, so the learning center 2 is about to describe the pattern of the interference for the water wave, light wave, and sound wave here. Okay, so to describe the pattern of interference, you must also understand, okay, so the relationship for this formula for each type of the interference. Okay, for water, for the light, and also for the sound. Okay, so you need to relate the lambda, which is represent the wavelength. Okay, wavelength of the water wave, sound wave, and also the light wave. Okay, then the A will be the, just now you can see to form the interference of the wave. So we need to have two coherent sources. So the distance between two coherent sources referring to A lah. Then X will be the pattern of the interference. So we need to know the distance. Later you will know what is the X meanings lah. And then the D will be the position of the source and the point where we want to see the interference. Okay, so simply say you need to use this formula, okay, to relate these four terms here. Okay, and then the learning center 4 will be problem solving involving interference of the wave. That means you need to use this formula, okay, for each cases for interference. Okay, so first will be discussion regarding the interference of the water wave here. Okay, so this is the activity from your textbook. Okay, page 212, activity 5.91. Okay, so here I already simplified. Okay, so firstly, interference of the wave can be produced and observed with the ripple tank. So this one referring to the water wave. Okay, will be water wave. Okay, so the procedure here will be discussed for two types of the interference of water wave here. So firstly, we're using 2 gate. Okay, we're using 2 gate. And another one will be using 2 sphere stipple. Okay, so here, if you enlarge the parts here, you can see we have 2 gates, 2 openings here. Okay, so they will be the coherent sources for this experiment. Okay, so use 1 plain wooden vibrator connected to motor. So here lah, firstly we need to creating the plain wave. Okay, so the vibrator must be vibrate the plain vibrator. Okay, then second, providing 2 small gate will be like these 2 in the ripple tank. So this is the sources of the coherent source here lah. Then the 2 gap will act as the 2 coherent sources. Okay. So here when 2 coherent sources, this will be the opening or the gap here. Okay, so when 2 of the coherent sources overlapping to each other, you can see here they are overlapping to each other. Okay, so you can see from this figure, so they will be have the dark region, they will be have the bright region, and they will be have the gray region here, right? So this is what we call as the pattern of the interference lah. And here will be referring to the water wave. Okay, will be, you can see here will be the dark region, here will be the white or bright. Sorry, this part will be dark, this will be bright, and here will be gray. Okay, so and the pattern of the interference of the wave can be also shown by this schematic diagram. Okay, so the line here, back line here will be the crest, and then the dashed line here showing this is the trough. Okay, so why there is a dark area for the pattern of the interference here? So because the trough of the wave meet another trough of the wave, so become the negative maximum amplitude, so become dark area. Okay, and then the second, okay, so this will be shown by this schematic diagram. Okay, you can see the dot line meet another dot line. Okay, so when both of the trough meets one another, so they will be formed dark region, which is a negative maximum amplitude area. Okay, then there will be another 2 also the same. Another 2 point also the same. Okay, and then the next here, you can see here we have the bright region. Here will be the bright region, bright region. Okay, so the bright region here is due to the overlapping of 2 crest wave. So will be form the bright area. Okay, so here we see okay, so you can see the 2 line here showing that this is a crest line meet one another. So the bright area will be formed. Okay, so here will be another one. So you can see here for this line, there will be consecutive of the bright region and bright region. Okay, so this is the line is where we know as the constructive interference occur. Okay, and we know as the anti-nodal line when we join the line together. Okay, so we know as the anti-nodal line. Okay, and then the next here will be the region. Okay, so this is a gray region. You can see like a straight line, right? Okay, so this is the gray area where the trough and the crest will be meet. Okay, so you are say showing by the schematic diagram. Okay, so there will be the point. This is a point. Okay, besides that, you can see we have also others point where the trough and the crest meets and form the gray area. And this we know as the destructive interference area. Okay, and then the line, when we join together, we know as the nodal line. Okay, you can see here, the anti-nodal line is formed from the dark, bright region next to the dark and bright and dark again. So here will be the anti-nodal line because this is a constructive interference occur area. Okay, and then for the blue circle here, all is actually from the overlapping of the crest to the trough wave here. And then the line, when we join together, we know as the nodal line. Okay, then the second experiment, okay, where we want to see the interference of the water, wave will be using 2 spherical dipper. So for sure that the source for spherical dipper will be in circular. Just now 2 gap will be actually plane wave and then pass through the gap and form the circular interference pattern. So here the 2 spherical dipper overlapping each other. So the source is actually from 2 circular wave. Then the overlapping also will be formed. You see from this figure, will be also form the circular wave and they overlapping each other. And we will see actually the same pattern of the interference. Okay, so let us go through together. Okay, so use 2 round dipper operated by the same motor. Okay, so same motor vibration, so that means the frequency of the wave will be the same. Okay, so the 2 round dipper will act as the coherent sources. Okay, so you see this is very important to creating the interference of wave with the 2 coherent sources. Okay, where the source must be same wavelength, same frequency, and also the different phase must be constant. Okay, so you can see the effects actually almost the same now. Okay, so this is GIF. You can see the dark and bright fringes will be at this area. So again, the dark area is due to the two trough meets one another. Then the brighter area here will be two crests meets one another. And then here you can see a line. So we consider a gray area where one crest wave meets with another one trough wave here. Okay, so this is the detail. Okay, so you can see here will be the line with interface bright and dark area. So that means the dark region and bright region will be repeating here at this part. These parts also. Okay, so this is what we know as the interface bright and dark area. Okay, and then we have the gray color line here, you see, the gray color area. So just now I also explained already, it will be actually come from one crest meets another one trough here. Okay, so the bright area is come from the crest wave meets another crest wave. Dark area here will be come from trough crest meets with another trough wave. So will we have maximum negative amplitude for the resultant wave. Okay, so the red color line here will be formed when one crest meet with another trough, and also vice versa. So you can see here there will be zero amplitude, and you can see this is a gray color line here. Okay. Okay, so again we can represent the observation through the schematic diagram. Okay, you can see again. So there will be this is the dot where the bright area will be formed, because from the crest, crest and crest. Okay, and then here also the same. And then this point will be from two dash line. So it will be trough meet with another trough. So this line will be also the same. So when we join all the point here, where all the point here is anti-knot point, where the constructive interference occurs, so the line we know as the anti-nodal line. Okay, and then the next here, when we see this point, so there will be trough, the dash line, pink color dash line, meet the blue color line, which is represented by crest. So crest meet with trough will form destructive interference. So the point here we know as the knot. Okay, so here also the same. One crest meet with another trough. Another two here also the same. So all the line we join together we know as the nodal line. Okay, so this is the line where interface between the bright and dark area will be showing by anti-nodal line. Will be this bright area. Okay. And then the dark area will be here, these 2 points from trough meet with another trough. Just like I explained to you already. And then this is the constructive interference area. When we join all the line, we know as the anti-nodal line. Okay, then the next will be discussion regarding the uniform gray color line. I also explained already just now. Okay, so this will be the gray area where the crest meet with the trough. So it will be this online. Just now I'm using these parts, actually also the same line. Okay, so when we join together, so this will be the destructive interference area. Okay, and we know as the nodal line. Okay, so then here we need to discuss the interference pattern of the water wave here lah. Okay, so at the point of the constructive interference, the water move up and down with large amplitude. So the large amplitude can be referring to maximum amplitude. Down larger amplitude will be referring to trough wave meet to another trough wave. So simply say they will be form of the constructive interference. Okay, so second, the point of the constructive interference is known as the point is known as the anti-node. Just as I mentioned to you already. So all here is the anti-node. Okay, will be this. Will be this. Then the destructive interference, the point we know as the node, okay, will be at this area. Okay, so where the one crest meet with one trough, or one trough wave meet with another crest wave, will be this all line. And then the line we join together, we know as the, okay, so this is the all point we join for the constructive point. So the line here will be this anti-nodal line. Okay, then for the point where we join all the point for destructive point or the node. So the line here we know as the node line. Okay. And here will be discussion for the formula. Okay, so the wavelength of the water can be calculated by using this formula. Okay, so the A will be the distance between two coherent sources. Will be these two point distance. Okay, then X will be the distance between two connective nodal line or anti-nodal line. So that means can be from anti-nodal line to anti-nodal line, the distance, or you can discuss from here to here, nodal line to nodal line also can. So this will be the X. Okay, then D will be the perpendicular distance from the source to the position where the X going to measure. For example, we measure the X at this dashed line. So the distance will be here to here. So be D. Okay, so we go to the question regarding the interference of the water wave. Okay, so this is the question from 2005. Okay, so the diagram shows the wave pattern formed by wave from two coherent sources, S and Y. Okay, so destructive interference occur at which part? Okay, so this one we need to see one by one. So for the destructive, okay, so you can see the first point P. P will be here. Okay, so P will be crest, the straight line here showing that this is a crest. So you see crest meet to another crest. So the P will be constructive interference. So we up because you want to get destructive interference. Okay, then we discuss point Q. Okay, so point Q here. Okay, point Q here will be one straight line crest meet with the dash will be destructive. Okay, so it's what we want. And then the next point will be P. Okay, R. So you see R is from dash line meet with another dash line. So there will be trough meet with another trough. So it will be negative maximum amplitude. So this one also constructive. Okay, so the answer here will be only Q. So answer is B. Okay, and then the next question number 6 is from 2013. Okay, so diagram 18 show an interference pattern. So it will be like this. So what is the wavelength of the wave? So this is a problem solving for the interference of water here. Okay, so for wave, so we need to apply the only one formula we learned in this part. So with this, so you need to get the value of A, X, and D. So what is A? Just now I mentioned to you already, there will be the distance between two sources. So be 2.0. Okay, and then we want to get the X. So the X will be the distance between two consecutive northern line or anti-northern line. Okay, so here will be 2.5. Then D will be the distance between the source and the measurement line for the interference pattern we want. Okay, so will be 7. So we just substitute and then we will get the value. So answer is very clear, will be B. Okay, then the next here will be question number 7 from the past year question 2019. Okay, so here diagram 2 show, so this question will be the example question for section A. Okay, so the diagram 2 shows the interference pattern of the wave produced by two coherent sources P and Q. Okay, so what is the meanings of coherent sources? So just like I mentioned to you already, so we have 3 important characteristics need to discuss. One will be frequency, second wavelength, both must be the same. So, okay, so you can choose right either one, but must come together with different phase must be constant. Okay, so the answer, coherent sources are two sources of the wave which produce a wave with the same frequency, same wavelength, and the phase difference is a constant. Okay, so 1 mark. Then second, so you need to draw the anti-northern line. So the anti-northern line, you have 2 options, to draw crest to crest, trough with trough. So that means one wave with from the crest meet another crest, trough wave meet another trough wave lah. So here will be here, 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 and here, right? Okay, so you need to draw a line. So this will be 1 mark. Okay, so 1 line is enough because the question requires you to draw 1 line. Okay. Okay, you can see the point will be here. Again, you can see will be red, showing this is a crest, meet with another crest. Then the ring will be trough, meet with another trough. Okay, so here we very clear out will be this line. Or actually you can get from this line also. Okay, because this is also the part where they meet together, showing this is the anti-northern line, where the constructive interference occur, or this line. Okay, then C will be the problem-solving question regarding the water wave interference lah. Okay, so here, information that related the interference pattern is shown in this diagram, and this listed in this table already. Okay, so you need to calculate the 2 consecutive anti-northern line. So that means we need to calculate value of X. Okay, so here the distance between P and Q. So P and Q here is the distance between 2 coherent sources. So it will be represented by A for the one and only formula for this subtopic. Okay, so here you need to rearrange now because we want to get X. So we rearrange the formula. So we get X equal to lambda D over A. Okay, then we substitute all the value. So the A will be here, which is equivalent to 4.0. So we put 4.0 here. D very clear is 20, we put here. Then lambda will be 1, we put here. So all is same unit, you don't need to do anything. So your answer will be in cm also lah. 5.0 cm. Okay, so here 2 marks given, 1 mark will be for substitution. Second mark will be given for the answer with correct unit. Okay, so here because we get exactly value. Okay, so 5.0 enough already. If I say there is a longer decimal places, you need to show minimum 2 decimal places lah. Okay, and the last D, what happened to the distance between the two consecutive ending of the line? Okay, when P and Q increases. So that means, firstly, we want to see what is the effect of X when P and Q increases. So that means the A increases. So again, we're using this formula. When A increases, here, so the X will be decreases. Okay, we're using this formula to do for this question, the relationship. Okay, when A increases, X will be decreases. So answer here will be decreases. Very straightforward. Okay, and then B, we discussed about the interference of the light wave. Okay, so here diagram A shows the arrangement of the apparatus in Young double slit. So this will be the Young double slit experiment, okay, to study the interference of the pattern of the light. Okay, so this is the experiment. We know as a Young double slit. Double slit, that means double gap. So again, double gap will be, we want to see the interference of the wave occur. But here we go to second type of the wave, which is a light wave. Okay, so the diagram B is showing the schematic diagram of the Young double slit experiment. So you can see this is a laser light actually. So pass through two gaps will be this. So the distance between two gaps will be A. Okay, so when the light overlapping each other, you will see the pattern of the interference of the light will be appear like this. So we have the bright, dark and bright fringes. Okay, one and others, repeating one and others will be like this. This is the interference pattern of the light wave. Okay, so the interference of the light occur when two coherent sources overlapping each other. Okay, so the monochromatic light sources is light with one color or one wavelength. So that means monochromatic light referring to one type of color. Example, red color of the light, which is about 700 nanometer. Okay, so for the visible region, so they will be from red color to violet color. So the longest wavelength will be the light ray. Then the shorter one will be the violet ray, about 400 nanometer. So the red will be 700 nanometer. Violet will be about 400 nanometer. So that means from red color light to violet, so the wavelength decreases. Okay. Okay, then the next here will be, again, there will be constructive interference and destructive interference occur, just like the water wave. Okay, but here, the constructive interference here will be formed bright fringe. Then the destructive will be formed the dark fringe. Okay, so it will be like this. So when constructive interference occur, bright fringe is formed. For the destructive, dark fringe will be formed. Okay. Okay, so again, we're using the same formula. So the A will be the distance between two coherent sources, the light, the gap between the opening for two slit here, okay, the distance. So the X will be the consecutive two bright fringes or consecutive of two dark fringes. Okay, then the D will be the distance between the sources to the screen, the transparent screen where we want to see the effect of the or the pattern of the coherent, the effect of the interference of the wave, light wave here. Okay, so again, you see A will be distance between two double slit A. X will be distance between two consecutive dark and bright fringes. Dark or bright, so dark will be together with dark. White will be together with white. So the D will be distance between screen and the double slit. Okay, so here we go to the question. Okay, so in Young double slit experiment, red fringes are formed on the screen. Okay, so when the red light source is used. Okay, so what will be observed when the red light changes to blue light? Okay, just like I mentioned to you already lah. Okay, at the visible region, the wavelength will become shorter from red light to violet. So the blue will be shorter wavelength compared to light red. So we want to see the effect on the screen. Okay, we want to observe the changes here. So you can see just now I mentioned to you. So when wavelength changes, so the X here will be changes lah. Actually, you want to see. Okay, see, observe the bright and dark fringes. We want to see the pattern. So we want to measure the X. So will be distance between bright fringes or dark fringes. Okay, so the wavelength will be decreases as I mentioned just now. So we're using this formula. So when wavelength decreases, what is the effect of the X? So we need to rearrange this formula. We want to see the relationship between X and the lambda. So it becomes like this. Okay, so when the wavelength decreases, so the X will be decreases. Because X and lambda is directly proportional to each other. So answer is C. Okay, then the next here will be question number 9 is actually also almost the same question, just the pattern of the question changes. Okay, so let us read the question together. So diagram 23 shows the fringes obtained when red light is used in the Young double slit experiment. Okay, so which of the following fringes are observed when the red light is replaced by blue light? See again, you can see this is a wavelength decreases. So the effect will be the different distance between the bright fringes will be decreases actually, right? Okay, so you see this is changes we want to see. Okay, so what is the effect when wavelength decreases to distance between two bright fringes here? Okay, so again, you can see just now I mentioned to you, when red light changes to blue light, so the wavelength will be decreases. With this formula, you need to rearrange. You get the relationship between X and lambda. So when lambda decreases, X will be decreases. So answer, you can see A is X decreases. So answer is actually A. So B wrong because the X increases, suppose decreases. Okay, C remain the same, right? C, but you can see the fringes size smaller. So the fringes size actually remain the same when just the wavelength changes. Then D definitely wrong because the size of the fringes smaller and the X increases. So answer will be A. Okay, then we go to question number 10. Okay, so this is a problem solving question regarding a light interference. Light wave of the interference now. Okay, so here you can look at the question. Diagram 24 show an interference pattern formed by the Young double slit experiment. Okay, so given value A, D, and lambda. So the question asking you to find the X. So again, we're using one and only formula. So we want to calculate X. So you need to rearrange and get this. Okay, so all the value is given. A equal to 2 times 10 power negative 2. D equal to 3.0. Lambda equal to 6.8 times 10 power negative 7. All is in same unit, so very easy. You just substitute, then press your calculator. You get 1.02 times 10 power negative 4. Okay, so answer will be C . Okay, then the next here will be question number 11. Okay, so again, this is a problem solving question. So now, just the difference here, the question asks you to find the wavelength. Okay, so diagram 20 shows the fringe pattern in a Young's double slit experiment produced by two coherent sources. Okay, so here is the value, is the distance, and this is a A actually. So the screen is placed at distance of 2.3 meter from the slit. The successive dark fringes distance is this value. This will be X. Okay, this will be X, where also show in this figure already, you see. Okay, then here we have another value. The screen is placed at a distance of 2.3, so this is D. Okay, so we're using this formula. We substitute all the value given. A with 5.0 times 10 power negative 4. X 3.0 times 10 power negative 6. D 2.3. You see all is in meter. So you just substitute, straight away you get the value. So it will be 6.52 times 10 power negative 10. So answer is D. Okay, so students, we may take a break for a while. Then later on, we'll continue the last interference effect for the sound and the application. Okay, hello, welcome back. So again, I want to tell you that if let's say you want to get my worksheet for today's lesson, you may get through this link via MO email. Okay, so let us continue to our last interference of the sound wave. Okay, for the learning center 2, 3, and 4 regarding the sound wave. Okay, so this is an experiment where we want to observe the interference of the sound wave. So will be A, like diagram A. So showing the arrangement of the apparatus in the star to study the interference pattern of sound. So you see we have the 2 speakers, okay, with the distance of A. Okay, and then the listener will be listen. Okay, so the effect of the interference of sound with the distance where D from the loudspeaker. Okay, so B will be the schematic diagram. Okay, so again, so what is the observation can be made by the listener? So you can see this is a line where the listener will be walk. Okay, so walk along this distance from here, if with the distance to the loudspeaker, so actually can hear L, which is a louder sound, and then S will be the softer sound. So we'll be repeating like this now, which is showing by this figure. You can just see L will be louder when the listener reach this position, and sound becomes softer will be at this position labeled with X. And then another point here, L louder again. So distance between L to L, so will be X. So it's actually the anti-northern line. So if I say X, S to S will be 2 point where known as a node. Okay, so this is actually the nodal line for the X area. Okay. So interference of the sound occur when two coherent sources overlapping each other. So that means here the audio generator play an important role to generate the same frequency of the sound, so that the sound come from the loudspeaker will be coherent. Okay, so audio generator is connected to two loudspeaker to produce two coherent sources. Okay, so as I mentioned, frequency must be the same for the audio generator here. Okay, so the superposition of the two coherent sources of the sound will be produced constructive interference and destructive interference also. Okay, so just now I mentioned to you already. So when constructive interference occur, so the sound will be louder, will be represented like L here. Okay, so when destructive interference occur, there will be soft sound produced. So it will be S. Okay, again, we're using this formula to calculate the wavelength of the sound. Okay, again, A will be the distance between two louder speakers for sound. Okay, then distance between two consecutive loud or soft sound will be X. So you can measure L to L consecutive or S and S. Then the D will be the perpendicular distance of the sound of the loudspeaker to the listener. Okay. Okay, so we straight go to one of the question. Here will be the 2011 question. Then will be example question for section A regarding comparison between two figures. Okay, so diagram 6.1 and 6.2 shows experiment on a sound wave. Okay, so here's diagram 6.1 and 6.2. So firstly, observe diagram 6.1 and diagram 6.2. Compare the X. So the X will be here. Okay, we want to compare X, which is between two consecutive loud sounds in these two situations. Okay, so you can just observe the diagram. Okay, you can see diagram 6.1 X is greater, right? So you just give the answer 6.1 greater than 6.2. Okay, then, okay, so thank you, Cikgu Hasnitah, for joining my class. Okay, then the next will be the distance between two loudspeaker here. Okay, so will be A. So now we want to compare A. So you can see A, the distance is shorter for the 6.1 compared to 6.2. So here you can straight away give the answer diagram 6.1 is smaller than 6.2. So the relationship between A and X, so you can see when X increases, A will be decreases, or vice versa. So here, the distance A decreases, the distance X increases. Okay, then we go to the next question. Okay, so number 4. So state one physical quantity that needs to be fixed to ensure the relationship in A3 is correct. So it will be A and we study relationship between A and the X. So again, we're using the formula. Okay, so this is the diagram just now I show you. So the A3 tests about the relationship between X and A. So which is inversely proportional. So what is the other physical quantity should be constant here. So we're using this formula. So here we rearrange X with the A. So you can see here we have lambda with D. So lambda and D here must be constant lah. Okay. So when we study about A and X, so X and D must be constant. So the answer here can be the wavelength or frequency of sound must be the same. by using the same audio signal generator. Or you can discuss about the distance between the loudspeaker with the listener. So the distance must be keep the same. So this is one of the answer. Okay, I give the distance between loudspeaker and listener. Or you can give line of the interference you want to measure. Okay, then the next, what is the physical phenomenon involved? So this one will be interference lah. Very straightforward. Okay, then B. Okay, so the question will be like this. So the frequency of the audio signal generator is increased. Okay, so now the signal, the frequency changes already. Okay, so firstly the question asks you to give the meanings of the frequency. Okay, so here the answer will be numbers of complete oscillation per unit of time. Okay, so this one is you just memorize, then you can give the answer. Okay, if possible, please avoid to just give the formula lah. Okay, then second, what happened to the distance between two consecutive loud sound here? Okay, so you see when frequency increases, what is the effect to the X? Again, we can using the formula to help us to get the answer here. So the formula is very powerful actually for discussion of the relationship. Okay, so here, okay, so from this formula, we cannot get any relationship between frequency to X, but we can get from previous formula we learned. We know that V equal to F lambda. So lambda will be V over F. So you substitute V over F to lambda. Okay, so you'll get this new formula, Vd over Fa. So from here you can see frequency increases, so the X will be decreases. So answer here will be decreases lah. Okay, then the next here will be give one reason for your answer. Okay, so the answer very clear lah. Just now mentioned already, when F increases, so the wavelength is actually will be decreases and causes the X decreases. So answer, when frequency increases, the wavelength will be decreases lah. Okay, then now we go to our last learning standard 5. Okay, this is discussion regarding the communication on application of interference of wave in daily life. Okay, so the application of the interference of daily life is actually covering to the sound wave interference, water wave, and also the light wave. Okay, so firstly we discuss the application of the interference of sound wave to our daily life. Okay, so here you can see we have the headphone. So headphone is here. Okay, so headphone used by pilot have a microphone and a transmitter system that produce a sound wave which interferes destructively with the surrounding noise. Okay, so from the figure you can see. So normally if I say you experience to take a flight, so normally very noisy. Okay, so the noisy will be the source of the external. It's the external sound for the sound wave you can see represented by the orange color. Okay, so to eliminate the noise, we can actually create another sound wave through the headphone here. Okay, so to destructively the surrounding noise. So you can see here, end up the red color wave is actually generated by the headphone, and then the yellow, so the orange color one is actually produced by the surrounding. So you can see they cancel out each other. So that means here is actually the destructive interference. So they will be silent for the pilot who using this headphone. Okay, then the second application will be at the line wave. Okay, so here you can see this is application at your spectacle. Okay, so you can see some of the person when they're using normal lens, okay, without the anti-reflective coating. Okay, so they will have the image appear on the lens. But if I say we have the application for the anti-reflecting coating, so there will be less reflection will occur. So why? You can see here. Okay, so the coating on the surface of anti-reflection lens causes reflected light to interfere destructively. So again, you can see from this figure. So this is a normal glass. So when outside the light hits the glass, so there will be reflect. Okay, so but if let's say we put the reflecting coating, you can see there will be another arrow which is showing that another reflected light appear here. Okay, so when these two lines overlapping each other, which is interference effect, right? So this is a destructive interference occur, you can see. So there will be less reflected light to your lens already. Okay, so this is to prevent any image form on the lens and to get a clearer vision. Okay, then the last will be the discussion regarding the application of interference of the water wave. Okay, so this is a bubble bowl at the ship. Okay, so with these parts, or we can know as bulb also. Okay. Okay, so the bubble bowl generate water wave which interferes destructively with the water wave around the hose. So the hose will be produce you can see from this figure, yellow wave. Okay, so this will be considered as a resistance for the ship to moving, and this will have more energy usage, so the consumption of the fuels will be more. Okay, so to decrease the drag or the resistance of the water, so the bulb here can be built up, okay, because can generate another wave which is showing by the red color wave here. So they will be cancelled out each other. Okay, just like this figure. Okay, so the first figure here is actually the conventional bowl. So they will be form the resistance because this is a wave is very high. Okay, so now you can see if I say we have only the bulb, which is this part. So another wave will be formed. So when both of these together will be just like this figure. Okay, so the resultant wave will have smaller amplitude. Okay, so this makes the water around the ship to become calmer and thus reduce the water drag. So the drag will be the water resistance. Okay, so thus save the fuels consumption. Okay, so this is all the discussion of subtopic today. Okay, so thank you everyone who is joined my class today. So please click like and share the link of the today's lesson to your friend so that more will get benefits from this sharing. Okay, and then please don't forget to follow the next physics classes, okay, which is at every Friday. So 9:30 p.m. will be for Form 5 Physics. So the next class will be for Form 5 will be 7.2, the photoelectric effect, and then for the Form 4 Physics class will be on every Sunday, 3:30 p.m. Okay, so the next will be 5.7, electromagnetic wave. Okay, so next week is actually the Diwali holiday week. Okay, so here I want to take an opportunity to wish all Hindus, students and teacher happy Diwali, and others will be happy holiday. Okay, so that's all from me. Okay, bye bye and see you again.